This video will cover the topic of refraction, GCSE physics stroke combined science topic. Hopefully it's a short topic, and the key learning questions which you need to be able to answer after watching this video is: what happens when waves refract? When does refraction occur? And how does a change in the speed of a wave affect its direction? Hopefully the topic is not too long. Okay, just a quick recap on what we mean by reflection. Simply, reflection, I would say, is a ball bouncing off a wall, hits the wall and comes back. That's reflection. When we see ourselves in the mirror, that is reflection. So a ray of light hits the mirror, we call that incident ray, and then a ray of light that comes back is called reflected ray. So this is just background, just to understand what reflection means. The main thing is we want to look at refraction. There are two key things to understand with refraction, and this is something I would embed in my mind. Refraction is when a wave changes speed and changes direction when it moves from one medium to another. And a medium simply means like air into water, air or water into mud, shallow water into deep water. This is all called a medium. So sound waves and light waves change speed when they pass between the boundary of two substances, i.e. air and glass, because air is less dense compared to glass. They also change direction, and this is refraction. Okay, now please note something that's really important. Refraction does not happen if they cross the boundary at an angle of 90 degrees, because the wave will carry straight on. There is a diagram on the coming slides which will explain to you this in a bit more detail. Please remember, sound and light waves behave just like water waves. Okay, now let's look at this then. Okay, here's my first diagram, this one here. If you notice, this orange arrow line with an arrow basically shows you a light wave or the light ray traveling along the normal, i.e. at 90 degrees to here to this boundary. It's not changing direction, whereas this is the most important diagram, the second one. Normal is just an imaginary line which is drawn at 90 degrees to the boundary. In a dotted line, we place a light source here which we call a light ray. So that light is shining, hits the edge of the glass, and what do you notice? It's changed direction towards the normal. It slows down, and then when it goes from water to air, it moves away from the normal. And this changing of direction is called refraction. So these waves here, which I'm circling, are called refracted rays of light. Or just say refracted rays to keep it nice and simple. And you can see, if I was to draw a line, let me see if I can highlight this in a different color, or if I can, let me change the color to red, and you can now see, if I continue, that red ray means it continues straight, and obviously if you look at the orange ray of light, it is not superimposed onto the red one, so it has changed direction. Here are some of the questions which you need to be able to answer. I'm not going to give you any answers here, just to summarize for you that refraction is about changing direction and changing speed. So describe what happens when a wave moves from glass to air and air to glass. All you need to do is go back to this diagram and use the diagram to answer these questions. Then we've got a toy car. There's a patch of sand. It goes into the sand. What will happen to the direction of the toy car? And question 3 is very similar also, in the sense that the toy car now goes in at an angle. This red ray would be your normal ray, and then see what happens to the direction of the car. Now, important one now, last one. This is higher, this is covered for the higher tier, or if you're doing the higher tier for GCSE. What we see here is waves are moving from deep water into shallow water here. So look at these lines. I want you to look at the difference between these lines, and when they hit the boundary, what do you notice? Okay, so you should be able to see as the wave travel, the wave or the red light shows the direction in which the wave is traveling. Then you can see these lines are getting closer together, and this means that the waves are slowing down, or the part of the wave slows down. So the key things to look at or to focus on this slide is the following. Speed of waves is different in shallow water and in deep water. Light travels faster in air than in water or glass. As light passes the interface between one medium and another, changes direction and it changes speed. So for this diagram, here are the important points. The bend or the light bends depends on how fast it travels between the two media. The greater the difference in speed, the more the light bends. And the light bends towards the normal when it slows down, and it bends away from the normal when it speeds up, as seen in this diagram here. Okay, now just to finish off with this diagram here, we look at now the diagram above explains what happens when with light waves. The speed of the waves depends on how deep the water is, 1 point. Secondly, water waves moving from deep water into shallow water slow down and change direction. As you can see here, this part, just focus on here on this side, they are changing direction, they are slowing down because the difference between these two lines is shorter than the difference between these two lines. And the lines on the ray diagram show the direction in which the waves are moving. So it's the lines on the ray diagram, they show the direction in which the wave is moving, not the wave itself. So just the direction of the movement of the wave. And that's it really in terms of this topic of refraction, small topic, and you need to pause your video here to be able to answer those questions. Thank you.